problems when it comes to any sort of real-time data streaming. So, IoT is in our name, but in reality, there's a lot of other applications and use cases for MQTT. So, we'll give a background on what MQTT is and what PubSub is, and share some examples, talk a little bit about the platform, but I want to spend most of our time hands-on, showing what it takes to build an MQTT application. The one thing I won't show you is how to configure it at Akamai, because frankly, it's a two-screen configuration. It's very, very simple to set up. And one of the beauties of MQTT is really the complexity and the richness of the application depends on how you design the endpoints around it. So the broker in the middle, which Akamai is in the case of Edge Connect, is really passive. It's just providing governance, and there's no need to really go in and touch the broker after you've set it up, as an example. And I'm excited to announce that we have a developers page that I'll share with you now, or share with you at some point, where you can literally get your hands on an IoT and MQTT sandbox in about 30 minutes time. And instantly start subscribing to and publishing messages like I'll be showing you today. So first, just a background, MQTT is what's known as a pub-sub protocol. So, client server has served us very well. And it does so in scenarios where you have fan out. So if you have millions of devices or clients or machines or browsers, and they all need to get the same piece of information, well, that's awesome. You're bringing them back to a central point or a distributed point in the case of Akamai, and that's served us well. But IoT applications, messaging applications, chat applications, their data transmission looks very different. The classic case is a bunch of clients that are transmitting, fanning data in as opposed to a server fanning data out. It's because of these changes in how the data is being disseminated that a pub-sub model really lends itself better than client-server or request response in applications that are chatty or have a lot of real-time data transmission. So of these protocols that are pub-sub, MQTT is the most popular one. It's a protocol that's about 20 years old. IBM built it, and the first use case was for oil and gas remote exploration. So think of something out in an oil field that's running on a battery that lasts maybe 6 months, that's talking over microwave or cellular or satellite. It's those constraints that MQTT was built around. So it's a very lightweight protocol. It's a binary protocol, so there's no converting from UTF-8 back and forth. Very, very small. Like the payload for MQTT can be as small as 2 bytes, as you can see here, and yet the header can be as small as 2 bytes. The payload can be anything you want it to be. It can be an array, it can be a binary object, it can be a bunch of text. You're not really constrained with the payload, and it supports up to 256 megabytes. So, when I talk about uses for MQTT outside of IoT, the fact that you can support payloads that will effectively do content delivery or binary delivery really open up the applications that you can write for it. Some other features of MQTT, there's a built-in push mechanism. So the notion, if I go back here, is that each client connects to a broker. So all of the connections are going outbound from the client, inbound to the broker. And once that connection is established, there's a very lightweight keep alive that keeps the connection persisting. And it's through that persistent connection that messages can be pushed down. So if you think about all of the systems that we built over the years to somehow handle a push scenario, or for that matter, if you can't do push, a polling mechanism, MQTT solves all that right off the bat and says, we support push, the clients will constantly be connected to the broker, and you can push messages down at any rate that you'd like. Bunch of other features as well for MQTT. So you have QoS levels. We'll talk about that in a second. But you can set as a message publisher various levels that determine how hard the broker should try to deliver a message. So QoS levels go from 0, which is best effort, meaning I'm just going to send this message out to any connected clients and then discard the message, or QoS 2, which is I'm going to guarantee that that message is delivered to every client. And those messages can persist in the network for up to 7 days in a buffer. So if you have, for instance, a vehicle that's turned off that you sent telemetry to, if you turn it on 3 days later, that message still should be there. And then lastly, there's this concept of a retained message, which lasts forever. So you can basically, within a topic, set a retained message that says hello, or just generally persists for a very long time. And by the way, that retain feature starts to really open up a messaging platform to actually act as an edge database. Because if you can publish messages under topics and have them retained forever, what you've built is essentially a distributed edge database. So a lot of customers I talk to, we're actually working with them on ways to utilize the edge database as a serverless origin for content delivery use cases. So again, we're halfway through my description of MQTT, and I think I've mentioned once about IoT. So there's much more to do with this than just IoT alone. So, if we look at the adoption of the protocol, let me move over here. Our platform supports both MQTT as well as WebSockets as well as HTTPS. You can see there's a plethora of IoT protocols, but really MQTT is winning out. So MQTT is winning out both for traditional IoT use cases, but again, we're seeing so many more examples of it. I like to say we all probably have a MQTT client in our phones right now that's called Facebook Messenger. That uses MQTT as an example. So a lot of growth in the industry overall, and it seems to be all coalescing around this wonderful new protocol. So just a little bit about what Akamai does in that space. What I'd like to say in a simple way to describe it is what we're building is similar to what we did for CDN when it comes to web content delivery. Is a distributed system of thousands of machines that act as a single logical service. That's what we've done with our MQTT broker. The difference is when you're building a web application that uses CDN, statefulness and consistency doesn't really matter. I mean, our CDN is constantly inconsistent in terms of having cache somewhere and not here, and you can't really track state. But that's okay because HTTP is largely stateless. But with a messaging protocol, having to manage what clients are connected, do you have duplicate clients or not? Has each client received that message? What's the event log of the data being received? All of these require state. So it's really, really hard to do, but we did it thanks to our product architect who's sitting over there talking to Bill Wheaton. So wrapped around that messaging service, we obviously have to protect it. So we utilize the same certificate management system that we do for CDN. We have to authorize clients, so we can authorize clients through JSON web tokens or through client certificates. We need to provide some form of encryption, so there's TLS as well as encryption at rest. And then we can offer the service so that clients can publish or subscribe to it either via HTTP or via MQTT. So it's not just MQTT that you can use for messaging and for the protocol. And lastly, we have Edge Data Stream. So if you're familiar at all with Kinesis, we basically built Kinesis into the whole platform where you can receive an HTTP data stream of all of the messages going back and forth. And this is especially interesting like in a security realm. So if you put all of your devices, all of your IoT behind this cloud, you could receive an edge data stream coming from Akamai, which then you could load into a SIEM or load into a log analysis tool and determine if you're getting anomalous patterns of traffic and behavior. Just a couple of more text things. I talked about QoS levels within MQTT. Message ordering. This is really, really important, especially when you're sending telemetry. So making sure that the messages are recorded in the order that they came in, that's a key part. Retained messages we talked about, those are messages that live forever. Last will is cool. So clients can publish a message that says, if I go offline, send this message out to all of my subscribers. So if I'm dead or inoperative, make sure that they get this message, which might point them to another service, for example. And as I mentioned, this, it's a stateful service, and we deliver it in a stateful way. Just one more thing on authentication. Again, we support JSON Web Tokens. We have built-in DDoS resiliency, so this entire service sits behind the entire Akamai platform, so all the normal DDoS goodness that you get from Akamai, the messaging system can take advantage of that. And then, as I mentioned, we can do two-way TLS, so authenticate a client based on a certificate, which is pretty big in like industrial machine-to-machine applications. So, as an example, if we take apart the demo that we did today, your client devices first talk to Akamai CDN. You received a JSON Web Token from our Edge Worker service. This is the app that we ran for the demo this morning. And then once that JSON Web Token was received, the phone could then connect via MQTT to our Edge network, which then talks to our data backend. And that's pretty much it. The key is making that operate like a single logical service no matter where you are in the world, and that's exactly what it does. Just for the folks that are familiar with Akamai and wonder where this fits, as I mentioned, the Edge terminates this connection. It handles the certificate management. It handles the JSON Web Token validation and handles the TLS. And then from there, we have a back end that does the actual data replication, message brokering, and other cool things that we're going to add to this product over time. So let's jump into this. There we go. So I've been running a script in the background. So there's no shortage of MQTT clients that are out there. The Akamai platform is the only MQTT messaging service that supports the full specification. So if you look at competitive solutions, they might not do things like guaranteed message ordering as an example. Or they might not offer every QoS level, or you might be limited in the number of topics or the size of the messages, or what have you. But we want to make it so that you could literally load a Mosquito broker, local instance in your development center, build an application to it, and then when you port that to use Akamai's broker, there's no degradation in service at all. There's no need to rewrite because we'll support everything that the full specification says. So, the good news is there's no SDK. You can grab an off-the-shelf MQTT client. We recommend PAHO. So the Eclipse Foundation supports a PAHO client, that's P-A-H-O. And you can get up and running like in 10 minutes with the client. So in this example, what I've done is grabbed an MQTT client called MQTT.fx. It's basically the PAHO client with a GUI wrapped around it, connected to the broker, and it gives me the interfaces to do basic publish subscribe commands. And I've got a script running right now. If we look at the script, I have to cancel it. If we take a look at the script, very simply put, it's just simulating what you would find, say, in a smart city, where all of the devices, whether they're the stoplights, emergency vehicles, cars, road sensors, are all communicating. So very simply, I was able to write a load script. By the way, I'm a router guy, so this is all Greek to me, but I was able to figure it out and get it going. And then to look at some of this output, we've actually embedded the MQTT client via WebSockets into a web page. So this is just to illustrate the kind of things that you can do with MQTT. You can run it natively, you can run it in a browser, and as I mentioned, our messaging service supports HTTP as well. So if you don't need, for instance, the ability to do push, you don't have to have it at all. You can just simply use HTTP to send and receive messages through there. So the notion is with this, you can build data pipelines. You can say, I'm going to publish this data on this particular topic and grant access to that. And then those topic streams can be consumed by microservices. You can, for instance, pull one message stream down, perform some processing on it, and send it right back into the Edge database. So just going through how topic subscriptions and how the topic system works, it's a hierarchy, but it supports wildcards. So for instance, if you're subscribing, as I'm subscribing here to everything under demo, the pound sign is equivalent to an asterisk, so it'll match all of the topics that start with demo. And then if we take a look, I'm going to do a old eye zoom in here. We can see that there's a lot of different topics, whether they're road sensor, light, fire truck, but we're receiving the subscription on all that. And then on the publish side, as I mentioned, you can publish to a specific topic. Let me stop this script. That is the opposite of stopping. But there's a fair amount of features that a publisher can invoke as they're publishing messages. So we probably won't see this because my message stream is still running and catching up. But if I say hello, as I mentioned, I can set the QoS level on this. So I can either say best effort, meaning I'm going to just send the message to every directly connected client and then discard it. QoS level 1, which is I'm going to send the message at least once to all the devices. And then QoS 2, which is equivalent in the data world to like true linearized consistency, which means I'm not going to expire the message until I'm sure that every client has received it and has acknowledged that they've received it. And then, of course, I mentioned the retention aspect of this. So you can set it to retain. You're able to retain one message per topic. So one interesting thing that we're finding here is by basically publishing a bunch of retained messages, we can effectively use this as an edge database. So as I mentioned, now the uses of it are much greater than just messaging alone. It can actually be a persistent data backend for CDN or for other use cases or examples. Obviously, having a lot of CDN customers, we're talking to a lot of folks about using this as a serverless origin that they can call from Ion or our other delivery products. So this is still going. So where are we with time? Looks like we're better than good. Just wanted to point out a couple of more things. So developer.akamai.com, if you search for IoT Edge Connect, we just stood this up today. So there's a developer sandbox. Basically you register and you're given a broker along with some access tokens and a few preset topics and basically subjects that you can publish to, and then some workshops that you can work through if you'd like to do that. But we also do free trials and POCs for customers as well, where it's actually activated within your Akamai account. Again, I would show you the portal, but frankly, it's literally just typing in a broker name, determining which geography you want that broker to run in. So one important detail that I probably didn't talk about is the fact that we can isolate data by geography. So for instance, if you'd like your data to remain in the EU, we can isolate that geo so that your data is resident at rest and in transit within the EU alone. So there's not really much to setting this up at Akamai. Frankly, the magic, as it should be, is around how you use it, how you organize your topics, and how you invoke it through the client. So, like I said, pretty hands-on. I don't have a flashing light demo, but I wanted to show the underpinnings of how you might build something like that. And yeah, this product's ready to go. So we'd love to hear the use cases. I think, when we launched it, we had a few use cases in mind, but frankly, for every one that I thought of, customers have come to me with 10 more of, well, could we do this with it? Could we, can we store this with it? Can we host this with it? Can we run this process? So, really those use cases. Audio cut out for a sec. So do we have any questions? Is anybody going to go home or back to the room and give this a shot? Okay. Okay, good. Well, I'll come see me. I'll leave you my contact info, and happy to help get you up and running on it for sure. So definitely let me know. Thanks. Thanks. Hey, Paresh.
Stupid question.
Yeah.
So when GM is trying to publish, let's say, they have author then obviously. Publish to the brokers and
Yeah.
but they have to write the obviously the update that they're trying to send.
Yeah. Yeah, but they're thank you.